ladies and gentlemen, welcome back to 5 Minutes of Math. This is Mr. Lunsford, and I'm glad you joined me this evening. Tonight's homework is for the evening of May 15th, 2018, and we're looking at our SOL review. This is our exponent review. Let's get started. Alright, so we're looking at simplifying exponents, and I pulled this particular definition from mclph.umn.edu. So this is a school that I pulled this from. So our definition here says, what is an exponent? An exponent refers to the number of times a number or a base is multiplied by itself. So 2 to the third power, or 2 to the third power, means 2 times 2 times 2 equals 8. So 2 is our base, 3 is our exponent. And here's another example using variables. N times n times n times n is n to the fourth power. And that's all there is to it. Now, you all may be tempted to actually get a number out of this. You may actually look at this and go, all right, so we're looking at 10 squared, so it's 10 times 10, I'm just going to have 100. And I'm going to write that as my answer. That's not what we're going for. What we're trying to do is combine our bases to show you the exponential representation. So we're not trying to solve it, we're just trying to simplify what we see. And let me show you what I mean. Number one, we're starting off with a 4 times 4 times 4 times 4. And what that is 4 to the fourth power. Now, if you put that into your calculator, and I'm doing that right now as we speak, you will end up with 256. Now, I'm not going to write down 256. I just want to write down 4 to the fourth power. That's the answer for number one. So let's go on to number two. So we have 3/4. We treat fractions the exact same way that we treat our constants. So 3/4 times 3/4 equals 3/4 squared. Okay, now I'm going to tell you, when you all study probability again in later years and say algebra, algebra 2, trigonometry, you may see this kind of notation for probability. All right, so let's go to the next question. We have 7 times 7 times 7 times 7 times 7 times 7. We have 6 sevens, so that's 7 to the 6th power. All right, 7 to the 6th power. So again, if you count the number of times we multiplied 7 by itself, 7 to the 6th power. All right, so here we go. Number 4, starting with a 4 times 4 times 4 times 4 times 4. That's 5 4s. Okay, so we're starting with 4 to the 5th power. Now we have a different number. Times 5 times 5 times 5. 5, 5, 5, 5, and 5. Now, if you counted all those up, what you should see is 8 5s, okay? So, again, that's 4 to the 5th power times 5 to the 8th power. So, again, all we're doing is combining our bases together so we can show what they look like in exponential form, okay? Now, these problems so far have listed everything nice and neatly. What do you see in some other situations? Well, let's look at number 5. Number 5 has a 3 times 2 times 5 6 times 5 6 times 5 6 times 2 times 2 times 2 times 3 times 5 6. All right, so all we're doing is finding the bases that match. This is sort of like combining like terms, but again, we're not dealing with variables right now. We're just dealing with constants. So we have 4 fractions here that are all 5 over 6. That's 5 6 to the fourth power. We have 4 2s, so that's 2 to the fourth power. And the last one we have here, we have 2 3s here, so that's 3 to the second power. Now, could you come out with an answer? Of course, but the purpose for tonight was to show you all how to combine numbers to show them in exponential form. This is more of a review than anything else, and just a quick reminder. So this should have been pretty easy, and that's it. Y'all take care, and remember, math is not just about numbers. It's all about the relationships that surround us every day. Have a good one.